Okay, so from the last week's class, what we are going to do is we are going to take up things a little bit ahead and see how it goes. So by the last class, we did complete everything related to what we call as inverse functions, how to deal with them, right? So I'm going to still give you guys a reminder and then work on the problems real quickly. Okay, so the first thing is that I told you guys, if you have sine inverse functions, right? So if you have a sine inverse, say x equals to say y, I told you guys to keep in mind that the x values here is going to be always in the range of -1 to +1, and then the y values are going to be in the range of values of -pi/2 to +pi/2. Okay, so this is going to be the principal values, or what we call as the range and the proper domains of the sine inverse function. So this is important. Now the next thing was the cos inverse function. So cos inverse x equals to y. So in this one, if you guys remember, then here the x is going to be the same as the sine function. So it was -1 and +1. All right. And then the y coordinates, or the y values over here, will be between 0 and what we call as technically, if I draw the function of the cos, right? So we have to get up to here. So this is pi, right? So that is going to be pi over here, right? So you can draw it. So that's a cos function, and the cos inverse would be the reflection of it. So this was our cos related inverse function, okay, cos inverse function. And the tan inverse function, right? So in the tan inverse function, you guys can remember the x value was not bounded by anything, in the sense it's like it can go from plus infinity to minus infinity, no problem. And the y values over here, so we needed to take a particular angle. So I said we can consider the angle to be -pi/2 to +pi/2, not including the values in the ends, because if this is the tan function would be like this. So we can take the inverse of it. Okay, so that was quite simple, and we are going to keep it as simple as that, and we're going to solve equations based on equations and other things based on this. Okay, so you guys can note this down, and let's see how it goes. Okay, so you can take the tute. From the tute we can go to exercise number 6. In the exercise number 6, you can check question number 1 itself, right? So question number 1. Okay, so this is the what I'm going to do now is going to be a bit of a warm up, right? So warm up from the last week. So they are giving us, for the first question is sine into sine inverse of, here we have square root 3/2. So what I want you to understand is, technically this is some angle. Okay, so this is some angle. So root 3/2 will be given in our sine value pi/6. Then you have to understand, is pi/6 in the range of this. So this is x ne. You have to ask your question, is the x going to be inside of the range? Sorry, not the x, the output, the y value. Okay, so the y value, right? So is the y value, make a y hari, is it going to be between -pi/2 and +pi/2? So you have to pick an angle inside of that range. So it's clear that it should be pi/3. Then what will happen? Sine pi/3 square root 3/2. Okay, so that sounds stupid, but then that's how it is. Okay, so to question number 2. So on question number 2, you have cos, and then there is cos inverse of -1 square root 2. So then you have to ask, okay, so which value of cos will be giving me a -pi/2? So our angle range, okay, so our angle range is from 0 to pi, right? So our angle range is from 0 to pi. So 0 to pi in the sense these angles are in the first and the second quadrant. Then 1 over root 2 is given by pi over 4. So this is the angle we are looking for. So that angle is going to be pi minus pi over 4. So which is going to be equal to 3 pi over 4. All right, I hope you guys can remember this, right? So cos pi over 4 is equal to 1 over square root 2. Okay, so and then if I consider the angle from here to here such that the angle residing here is pi over 4, then this would be sine 3 pi over 4. So sine 3 pi over 4 must be the same value, but since this is in the sine quadrant, it is going to be a minus 1 over root 2. Okay, so we will be having here cos 3 pi over 4. So still our answer will be 1 over square root 2. So not always you can do the exact opposite. You can see like, cos into cos, the inverse of whatever this is the cos. So whatever the value was inside. You can't apply that exactly for everything, but keep that in mind. Okay. So moving on to question number 4. If you notice there, so here we have sine into cos inverse of half. Okay, so we have something like that. So what is our angle going to be? Now cos inverse becomes half when the angle is going to be technically pi over 3. Okay, so cos pi over 3 is equal to half. Because of that reason, now it is in our range next, so cos is going to be in these two quadrants, the first quadrant and the second quadrant, right? So that's fine. So that's the range of the angles. So now what are we going to do is we are going to replace this with basically pi over 3. So when you replace it with pi over 3, now you can see sine pi over 3. Sine pi over 3 must be equal to square root 3 over 2. So that completes the problem. Okay, so that was a bit of a warm up from the lesson we were working on. And we can do the opposite also. If you were to go on to question number 2. Now, you guys already know this is a recorded lesson. I've put the reason why. So, you guys can pause. Okay, so try the questions on your own. So, this is question number 2.1. So, we have sine pi over 2, right? Now, we are going to work this one out very nicely. Balanna sine pi over 2 putala is going to be equal to technically 1. Okay. Then we had was what will give us 1 for cos. So 1 for cos is given in angle of 0 radians or even 0 degrees is correct. And it is inside of the cos range as well. So no problem. Question number 2. This is sine inverse of cos pi over 2. So we know that cos pi over 2 is equal to 0. Then we have to ask which value of angle will give us sine 0. So that is exactly 0 radians. There we go. So we can do it like that. And if you were to work out the question number 5, so what we have there is cos inverse of tan 3 pi over 4. Okay. So tan 3 pi over 4 is there. So we'll work that one out first. So we can write tan. So 3 pi over 4 can be written as pi minus pi over 4 with the acute angle. Okay, so 3 pi over 4 is equal to pi minus pi over 4. I want you guys to carefully work that one out. And then you have to understand, I can write this one as tan pi over 4. So if there is a multiple of pi, okay, so integer multiple of pi, that means 1 pi, 2 pi, 3 pi, 0 pi, likewise, even negative values, tan becomes tan, sine becomes sine, cos becomes cos. And you have to figure out whether this is a plus value or a minus value based on the quadrant that they are going to end up with. So pi is the value that is ending up here from all the way there, and you are subtracting pi over 4 from that. So then your angle will be on the second quadrant. So therefore, this is a sine quadrant, and then tan pi over 4 must be a negative value of -1. So we are going to then insert here cos inverse -1. Now we have to ask, where does cos become minus? So that is going to be pi. Angle will be equal to simply pi radians. Okay, so we can try questions like that. So it's very easy. I want you guys to work on remaining questions and send them as a exercise. What are we going to do is, we are now going to work on slightly harder questions from the exam papers as well. Yeah, we will do that. Before that, we are going to take a look at some more difficult problems. As I said, you guys can pause and run the video, so no worries there, I think. So I'll erase this one for now. Hurry. Now if you take a look at question number 4 in the exercise, you can see question number 4, 1, you have sine inverse of 4 over 5, and then plus sine inverse 12 over 13 is there. Okay, so we need to figure out what is the answer for this question. So how do we do it? So what we can do is, we can first of all figure out what is this angle value. So this is a plus value now. So since sine become plus when you have acute angles, so that means I can put them into triangles without any issues, right? So this angle I will consider as to be alpha, and then this angle I will consider to be beta. Okay, so I'm going to first of all work out the alpha's value. So the alpha value I can work out nicely like this. I can say, so suppose the alpha is here, then 5 must be the hypotenuse, and the 4 must be placed here. Then by Pythagoras we can understand the adjacent side must be 3. Similarly, we can work out for the beta. Suppose beta is here, and then the hypotenuse values must be 13, and then 12 must be the opposite side. Then by Pythagoras, you can understand this must be technically 5. That is not very hard to understand. Now look what's going on. First of all, I am going to write this part as technically sine alpha plus beta. Okay, so those are the two angles, and we are going to expand this thing. So if you expand it, you can recall that it must be sine alpha cos beta, then plus, we can write this thing as cos alpha and then sine beta. Now when you look at this question over here, sine alpha we can directly obtain from here as to be 4 over 5, and then notice the cos beta is going to be 5 over 13. Cos alpha is going to be equal to 3 over 5, sorry, and then the sine beta is going to be equal to 12 over 13. Okay, now once we have these steps, we just have to simplify it. Simplify whatever we can, I would say. You might think, okay, we'll cancel off the 5s, but don't do that, because then we won't be getting a nice common denominator anyways. So we'll just multiply. So 5 times 4 is 20, that's 36. So we have 56 here. We're going to divide this by 5 times 13, which is 65. So that is going to be the answer for sine alpha plus beta. Okay, so you guys can pause the video, right? So write it down and work out question number 2. So on the question number 2, we have sine inverse. Sorry, this is not sine inverse, just sine, and then sine inverse 12 over 13 plus sine inverse 8 over 17. right? So we need to work this one out. So I will erase this part. You guys obviously can pause this. So if you were to work that one out, again sine is going to be positive in as if they are um, acute angles. So I'm going to suppose that this first angle over here to be alpha. Okay, so this angle is alpha, and then this angle consider it to be beta. Now what is going to happen is I'll consider this angle as alpha, and then it's clear from Pythagoras we can get the 13 there. Okay, so in basic trigonometric ratios, this must be 12 and this must be 5. And then also we have to get the beta. So the beta is going to be, if you look at this diagram, it's 17 here, and this is going to be an 8. And how much would this be? That'll be 25, so 5, and then 3. I think it's 15. Yes, I hope it's 15. Okay, right. I guess you guys can double check the values of that. And then I have to, as usual, I need to expand this thing. So expansion of this would be sine alpha plus beta. So sine alpha plus beta would be simply sine alpha cos beta, and then plus cos alpha, and then sine beta. So what is my sine alpha? My sine alpha is going to be equal to 12 over 13. And what is my cos beta? Cos beta is 15 over 17. Right? So cos alpha is going to be equal to 5 over 13. And then we have sine beta. Sine beta is 8 over 17. Now, it's nice if we had, things to be simplified, but it seems like not. So we'll need to work out this thing is okay. So let's try this out neither. So 15 into 12, so that's a 30. Sorry. So 180, and then plus, that's a 40. Then we have 17 over 13. So that's like 1, 3 to 51. And then we have 17, 1, 12, and 2 to 21. Okay. So we are going to get 220 divided by 221. So that is going to be the answer for question number 2 in the question 4. Okay, question 4, 2. Right.